Hey, we're going to do a quick video about how to label triangles because the labeling is going to be very important when you get to the laws of sines and the law of cosines. All right, so for any triangle we draw, all right, that's just a random triangle. Of course, we should realize that there are 6 components. There are 3 angles and 3 sides. All right, so altogether that makes a total of 6 components. Right, 3 angles and 3 sides mean there are 6 parts to any triangle, the 3 sides and the 3 components. Now, traditionally, we label the 3 angles with capital letters. Right, and that can be any capital letters, A, B, C, X, Y, Z, P, Q, R, it doesn't really matter. Traditionally, we tend to use A, B, and C. But the fact that I write capital letters means that they are the angles. All right, I never use, and for this chapter, we never use lowercase for angles. If you see a capital letter for a side, we are always using capital letters for angles. So this would be angle A, this would be angle B. It's a different angle, so I mark it differently. And this is angle C. They're all different angles because they probably all measure different amounts, okay? Now the sides are done by lowercase letters. All right, so lowercase letters. So you're going to use a lowercase a. So now, yeah, that's the thing. Whatever letters you use for the angles, you use their lowercase versions for the sides. So if I have triangles with A, B, and C, then my sides are also going to be A, B, and C, but the lowercase version. If this was P, Q, R, then my sides are going to be P, Q, and R, but the lowercase version. Which is why we don't use X, Y, and Z very often, because the lowercase X and Y's, or especially X's, they kind of look alike and they'd be very confusing. So that's why we tend to use A, B, and C's, because the lowercase versions are pretty different, except for C. So make sure you're really paying attention. All right. But here's the other thing. If we're going to call these sides A, B, and C, it's not totally random. We put side A from what we call its partner, and its partner is across from it. Angle A is right here. And if I were standing in that corner, I would be looking at this opposite wall. This is the wall, the side of the triangle that's opposite, right, from angle A. So we're going to call that side A. That's how I write my A's, okay? So that is side A. I can't put it over here because if I'm standing at corner A, pretend you're standing with your back to that corner and you're staring straight ahead, that's the side you'd be looking at. Now put yourself in corner B with your back against the corner and you're staring straight ahead at that side. That is the partner of angle B. That is side B. That's why I write my cursive side B. Of course, there's only one left, but if you visualize it, if you stand in corner C with your back against the corner and you stare straight ahead, you're looking at that side. So that is your side C. So it's important that the angles and the sides are always opposite each other, or sometimes we say across. Right, they're always opposite or across from each other. Right, it's not just this total random order. Okay, so if you had another triangle, maybe I'll draw like an obtuse one. Right, and we'll call this one like say maybe P and then Q and then R. Right, then this side would have to be what? P, Q, or R. Well, it would have to be P. I'll do a cursive P. Right, Q is over here, and R is right there. Okay, so you make sure you always label opposite from each other across. That's very important because sometimes we give you a picture, but sometimes we won't. We will just tell you the letters, and you should know capital letters always mean the angles, and lowercase letters always mean the side. Now, since there are 6 components, as it's going to turn out, if we give you any 3 of them, right, if we give you the 3 sides, through trigonometry, it's going to be possible to solve the 3 angles. If we tell you what the 3 angles are, but not the sides, we can figure out what the sides are. If out of these 6 components, as long as you know at least 3 of them, you can always find the other 3. How do you do it? Well, there's 2 ways to do it. One is called the law of sines, and one is the law of cosines. That's what you're going to be learning next. But yeah, the law of cosines and law of sines say that if you know any three of these six components, you can do it. Now, it doesn't have to just be the three sides of three angles. It can be any mix of them. So let's say I tell you that this angle is 120 degrees, and I tell you this angle is, I'm just saying, 31 degrees. Right? That's two sides, or two angles. Right? So that's not enough information actually right now. All right, because we're going to be doing what's called solve the triangle. If you see the words solve the triangle, that means find all the missing information you can. So if this is all I tell you and I say solve the triangle, all right, that means I need you to solve what angle Q is, what angle P is, and angle R. Well, I already know R and P, but I need to find angle Q, I need to find side P, side R, and side Q. All right, and there is going to be a way to do this, although we only have two of the angles. So we only have two of our six components. That's not enough. Now, if I also happen to tell you that side R equaled maybe 7 inches, now that is three components, two angles, and a side. Now, because we have two angles, we're going to say A for angle, an A for another angle, and then S for side. So we'd say this triangle is an AAS, meaning it's an angle, angle, side triangle. Now, you're going to see notations like this. Now, if I know all three sides, let's say this side is maybe 10 inches, and this side is 15 inches, and this side is 26 inches, I'm just making that up, then we would say we know all three sides. So we'd call that a side, side, side triangle. If you know all the angles only, then it'd be an angle, 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 or AAA triangle. But if you have a mix of sides and angles, you put them together. Now, this means you have two angles on the side. Now, this also means you have two angles on the side, but it is different. These two things are not the same, all right? An angle, side, angle means the side, you know, the position of the letters makes a difference. This means the side is between the two angles, something like this. I will scoot down a little bit more. Okay, I'll draw another triangle. All right, and say I know this angle. We'll call that an angle. We'll call that, like, say, 93 degrees, right? And then say I know some side next to it, say that's maybe 2 meters, right? And then say that angle, and that is maybe 15 degrees or something like that. So I know an angle, a side, and another angle. That is different from this, even though it's two angles on the side. No, here's why they're different. Take the side you know and kind of highlight it in your mind. I'm highlighting the sides I know. And then notice this angle touches the yellow highlighted side, and this angle, that both angles touch the highlighted side, because that's what we mean that this side is between or touches both angles. It's between them. Over here, this angle touches the highlighted side, but this angle doesn't touch anything. It's kind of off on its own. That's why this is an angle, angle, side, and this one is an angle, side, angle, meaning the side is literally between or touching both angles. This means only one side and angle touch, and the other angle is kind of off on its own. All right, so there is a difference between AAS and ASA. For the same reason, there's a difference between SSA and SAS. Right, those two things are different. Now, is there a difference between SAA? Technically, no. These two things are kind of the same. It means there's an angle on the side that touch and one angle that does not. An angle on the side that touch and one angle that does not. So they're kind of still the same scenario, all right? But these two are not the same as this one. This third one is different. So if there's two are the same and one is different, if that one is in the middle, that means that the one in the middle is between them, right? So an angle of SAS would be maybe something like this, where you have this side is 10, this side is 7, and the angle is between them. All right, so maybe that's 18. Right, that's an angle of side, angle, side. But side, side, angle, that could be like this. Here's a side 10, here's a side 7, but the angle that we know is over here. Or it could be in this corner. It could be in one of those two corners. But either way, it can't be in both, but it could be in this one or in the other one, all right? If it were up here, it would be a side, angle, side, because the angle will be between them. Over here, the angle, if it's this one, it touches the 7 but not the 10. And if it's this one, it touches the 10, but not the 7. It's always away from 1. Now, technically, if this is AAS and SAA, those two things are the same, then SSA and ASS are also the same, but because ASS doesn't spell a very nice word, we usually don't write it that way. So we always write it like this just to be polite, but technically they would be the same thing. Okay, so that's what, so you're gonna see the very important thing is knowing this, that sides and angles are always opposite of each other, angles are always capital, sides are always lowercase, and you might have various combinations of side, 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 angle, 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 side, angle, side, and so on and so forth. There's a lot of different combinations, and knowing what combinations you have will decide whether you use something called a law of sines to solve it, or a law of cosines, because certain combinations only work with law of sines, and certain combinations only work with the law of cosines. So we will be kind of talking about these different combinations later on. Now, one other thing you should know is that actually some of you may have noticed in this triangle, or also in this one here, if you know two angles, you actually do know the third angle, because hopefully know that the three angles in a triangle always add up and equal 180. So we call that the sum of the angles rule. The sum of the angles in a triangle always add up to 180. So you could actually solve for this missing triangle. If you know any two angles in a triangle, you can always find the third one. Now, if you only know one angle, then we don't have enough information. So over here, where we know this angle is 18, I have no idea what this angle is or this angle is. If I only have one, that's not enough. But if you know two angles, you could definitely solve for the third one by doing 180 minus 18 minus 13 or whatever I wrote there. Okay, 73. And that would get you the third angle that you learned in geometry a while ago. So hopefully you remember that. Okay, all right, so I hope that helps you out a little bit.